Okay, good evening everyone. We are on live stream. So it is a Saturday evening and we will conduct again our new live stream via our YouTube channel, Jack1 TV. So I know we have uh, attendees, virtual attendees this evening. Some of them are still in Singapore and so many other places. We were able to uh, inform the different Facebook pages as well as groups. So we hope that there will be more attendees this time. This very important topic is uh, very significant for those who are planning to become plumbing professionals, and of course even those new master plumbers in the Philippines, and even sanitary engineers need to know some of the items that are included in our discussion tonight. So so without much ado, we will now proceed and have our invocation. Okay, so let's bow down our heads and name Father, Son, Holy Spirit, Amen. Lord God, we praise and thank you for this opportunity to be able to conduct this YouTube live stream in order to share our knowledge. And we praise and thank you for giving us this chance to be of service to our younger brothers and sisters in the profession. And we praise and thank you for um, giving us this opportunity that would give them knowledge, skills, and increase their capacity, and hopefully they'll become more progressive in their lives using this knowledge. And of course, that will also redound to the betterment of our country in general. And Lord God, we also ask that you keep us away from this sickness, this COVID especially, and keep us away from accidents. All this, God, we ask on the mighty name of your Son, Jesus Christ, who lives and reigns with you forever and ever. Amen. So here is my very short resume. I've been a registered master plumber since 1989, so I already have over 30 years of experience in plumbing practice. And in electrical, I already have over 45 years of experience. And in mechanical, I finished my mechanical engineering in 1987. So in 1989, I started to do mechanical practice by installing gensets during the brownout years of President Corazon Aquino. And about over 10 years ago, I started to practice fire protection, and that doesn't include only sprinkler system but also air pressurization, FDAS, of course. We've been part of electrical engineering practice before. Now, I've been the first national president of the Philippine Society of United Master Plumbers way back in 2012. No, in 2012, a group of plumbing professionals, master plumbers, wanted to separate from the old NAMPAP. So we put up the new NAMPAP, which we changed later to the name Philippine Society of United Master Plumbers. And today, the incumbent national president of PISAMP is architect Eldred Tan of Cebu City. After me before, the second president was Engineer Armando Diaz, who was also the former national president of the Institute of Integrated Electrical Engineers in 2011. So with Engineer Diaz, we established the MEPF Organization of the Philippines in 2014, 2015, and today we continue to conduct these free seminars for the benefit of uh, the young MEPF practitioner. I presently operate FEMP Safety Engineering as my own company, and of course I do help MEPF Organization of the Philippines, being its training director. Okay, so now we'll proceed to our topic, uh, preparation of plumbing sanitary plans. So here is a list of a checklist of the what is included in the plans, no? So number one is plumbing sanitary general notes, and the next is plumbing sanitary legend, abbreviations, and symbols, and of course catch basin details, plan and section, septic tank details, plan and section, cistern tank details, plan and section, isometric layouts. Okay, then usually the isometric layouts includes that for water and also for the soil and for the storm drainage. Then of course schedule of pipe sizes per plumbing fixture served, plumbing layout for cold water lines, cistern, location and water meter including overhead tank, plumbing layout for soil, waste, and vent pipes, plumbing layout for storm drainage, downspouts, gutters, canals, catch basin area, connection and installation details, optional of course, and location plan. Of course, not included here are more details on, let's say, for example, rainwater tank and the firewater tank. Okay, so what is mentioned here is only the septic tank and the water cistern, so single water cistern. Today we already do rainwater collection. Of course, there must be a filter to this, and also the septic tank that we use today are much more advanced than what is being provided in the 1999 Plumbing Code of the Philippines. So here is a simple plumbing plan, which would include general notes here on the left upper left hand side, and below it are the abbreviations and legends, and the upper portion and the middle is the plumbing fixtures schedule. On the right side of the drawing is the catch basin detail, and here is a detail of the water cistern, usually an underground tank, water cistern, and here is a detail of the septic tank, which you will notice that it is no longer really compliant with the Clean Water Act. We just simply put it because we've noted that there are so many of our colleagues in the profession that still uses the old design. So we would like to use it as a means of comparison to remind our co-professionals of the correct way of or the best way to design the septic tank. Okay, here is a closer view of the general notes, so let's just go over it. Number one, all dimensions are in millimeters unless otherwise noted. Number two, all plumbing works shall be designed in accordance with the latest issue of the Plumbing Code of the Philippines. So take note, our plumbing code is 1999 vintage, so now it's already 2020. That means therefore that it's already over 20 years outdated, no? And there's the Clean Water Act in 2004, the Philippine Clean Water Act, which therefore would affect the Plumbing Code of 1999. All stocks shall be well supported at their bases and provided with appropriate clean-out fittings. Mid-span support shall be at every 2 feet and center. It is not intended that the drawing shall show every pipe fittings, valves, and appliance. All such items, whether specifically mentioned or not, or indicated on the drawing, shall be furnished and installed in, if necessary, to complete the system to the satisfaction of the client. Sorry for this topo error. No? Contractor shall be responsible in verifying and coordinating the following in accordance with manufacturer's data and recommendations. Number 6, proposed sanitary utilities shall conform to the actual location, depth, and invert elevations of all existing pipes and structures. Number 7, all water pipes shall be hydrostatically tested to pressure of 1034 kPa for 2 hours. Okay, note, mounting dimensions shall be verified based on manufacturer's recommendations. And note number 2, all horizontal branch pipes should have 2-inch or 2% slope. Okay, so let's proceed to the next slide. Here is the abbreviations included in this PowerPoint. So we have here the gate valve, the water meter, WM, check valve, CV, WC is water closet, FD is floor drain, LAV is lavatory, SK is kitchen sink, well, it should be KS, and SH2 is shower head, and UR is urinal, CV, AD is catch basin or area drain, F is faucet, HB is hose bib, DS is downspout, GT is grease trap, HT is house trap, FCO is floor clean out, CO is clean out, and VSDR is vent stack through roof, okay, or BTR is vent through roof. HP is horsepower, PPR is polypropylene resin, it's a pipe, LC is leaching chamber. Of course, the leaching chamber is no longer possible with the Clean Water Act. It should be settling chamber already. PVC is polyvinyl chloride. EWT is elevated water tank. RV is reducer valve. SWP is soil and waste pipeline. BP is bent pipeline. CWL is cold water line. HWS is hot water supply. HWR is hot water return. And D with these lines are drainage line. SS is soil stack, so it's around because it's vertical. DFR is downfeed riser, and UFR is upfeed riser. Okay. Now here is a larger view of those details earlier shown in the several slides earlier. You would see the detailed drawings of an underground cistern. Here is the underground cistern with the details of reinforcing bars indicated, and of course the ladder and the float here, the incoming water line, and a pump, of course. And what is very important here is, of course, must use a tiles as a finish to make it clean. And of course, this metallic furniture should be stainless steel, and the cover should be overlapping to make sure that water overflow or flooding would not enter the water cistern. Okay, now on the right side you will notice that I have added some notes here in red marks. No covers on the T's, and of course on the middle, no cross ventilation should be possible. This is an old design of the septic tank, a very common design which many of our colleagues, as I've said, have been using. So later on I will show you the correct way of doing the design and point out which provision of law would not allow anymore this leaching chamber. Okay, and of course take note that the sanitary T that is used here does not allow the movement of free air through inside the digestive chamber and of course the settling chamber, or in this drawing is the settling tank. And of course another thing is that because it is no more allowed to have a leaching chamber, it is already replaced with a 3-chamber design. The second chamber was converted to a 2-chamber a portion, which which no longer allows leaching. Okay, so that's very important. Doesn't allow any more leaching. So therefore, the word leaching is no longer proper, because when you say leaching, you are allowing the gray water to be absorbed by the earth. That should no longer be allowed. You know, I have seen registered master plumbers. Some are even colleagues in the profession, in the industry, signing and sealing plans which still use the old design with the leaching chamber. So and these engineers are either architects master plumbers or civil engineers master plumbers. So they do not know the laws that govern the practice of plumbing in the Philippines. Okay, so here is a tabulation or a matrix that would guide someone who would be designing the septic tank, no, and a fast way of designing it. So here is number of people served, no. So you have here 1 to 6 people, and this vertical line would indicate the different sizes of or the dimensions of the septic tank. Like for example, for this first column, 1 to 6 people in a house, then the inside width should be 1.2 meters or 120 centimeters, and the inside length would be 1.5 meters or 150 centimeters, and the depth of liquid would be 1.2 meters, and the inside clear height of the tank would be 1.5 meters. So let's go to an equivalent commercial or industrial septic tank. At the extremes on the right side, for a capacity for people that would use it, 75 to a maximum of 100, the tank would have an inside width of 3 meters and the inside length of 3.6 meters, and the depth of liquid would be 1.5 meters, and the inside clear height of the septic tank to be 2 meters. So that's how we apply this matrix to come up with a fast way of determining the dimensions of your septic tank. Okay, you can always follow the one that's provided in the National Plumbing Code and also in the book by Max Fajardo. It is always possible, but sometimes you want to do it faster, so you can just refer to a matrix like this one, and that would make you do the design job much faster. And here is the cross ventilation that I was talking about. What is this cross ventilation? This cross ventilation with the use of correct T, no, meaning to say these T baffles here or fittings are not extended to the cover, no. So they are just here. I just emphasize the distance between the top of the T to the bottom of the tank, just to emphasize the need for this air gap. So with this air gap, as I'm pointing out with the arrow here, it will allow the movement of free air. Say air coming from the drainage, from here, from the storm drainage outside in the street. Okay, the air would come in here, goes here, then enters this pipe, comes here again, and then enter this, and then it will pass through the soil pipe to the vent pipe, and will exit to the vent stack through roof, VSTR or VTR. How can it happen? Well, This happens during daytime when the sun shines and heats up the upper portion of the house, or heats up the roof of the house, and therefore heating up this pipe here. When this pipe here, the ventral roof pipe, is being heated, the tendency for the air inside the VTR, the hot air, would be to move out of the VTR pipe. That's a natural movement, natural ventilation, natural movement of air that is hot. Okay, any hot air would have the tendency to move up. So therefore, as it moves up there, it will create a suctioning of the air from here, getting inside there, like that, could pass through this vent pipe here, and then exits there. Take note that this only happens during the daytime, when it is hot. During nighttime, chances are this phenomenon would not really be happening during nighttime. There might be some movement of air, but would be minimal. Not like during daytime when the roof is hot and the ventral roof is hot. Therefore, the hot air at the upper portion of the VTR will move out of the VTR and suctioning, as I've said, the air inside here. What is the advantage of this phenomenon? Well, of course, this would supply air to the settling tank, to the settling tanks, and to the digestive chamber going out there. So, what is it? Well, the air there, therefore, gives oxygen to the bacteria, to the small living beings inside the digestive chamber. Remember that the digestive chamber has these bacteria that tend to eat the dirty particles coming from the waste, from the human waste. Okay? And with the entry of air and oxygen, therefore, it will strengthen this bacteria. Okay? And therefore, making them stronger, they will become more efficient, and they could process the dirty water faster. Now, if there is no air coming inside, because you think that the bacteria are anaerobic, then the process of digesting the dirty water, the sewage, the sewer water, would take very long. If not, the bacteria might die because of the absence of oxygen, and only a few would survive. If only a few would survive, then the process of digesting this dirty water would take very long. The effect is, every time you flush the toilets, the dirty water would be transferred from the digestive chamber to the settling tanks, and from the settling tanks to the drainage. And eventually, the water in the drainage will be smelled. No? It will be, it's bad because it is not yet totally processed. Okay, so that's the phenomenon. This phenomenon is not indicated in the books. It's not indicated in the book of Fajardo, not indicated in the Revised National Plumbing Code, and even other books that I've seen, even American books that I've seen, does not mention of this. Does not mention of this. We're just so lucky, yours truly was so lucky to be able to discover this in one subdivision project several years ago. There was the subdivision where the contractor replaced these T's to elbows, and when you replace these T's, sanitary T's, into elbow, you will be depriving the digestive chamber of the entry of this air that I'm talking about, which I will show you now later. No, so this is my explanation. Digestive chamber and the succeeding chambers of septic tanks can be improved by providing the vent at the outlet of the septic tank. This proposed vent has two functions. When simultaneous use of toilets at high demand, use the upstream vent the vent functions as a relief nozzle, thereby eliminating possible back pressure. Letter B, during standby condition, during daytime, meaning when no one is using the toilets or the plumbing system, the vent acts as an entry of fresh air and oxygen to the digestive chamber or settling chambers. The fresh air oxygen will help strengthen the microorganism or bacteria inside the chambers. The bacteria will tend to multiply faster and help hasten the digestive process, making the septic tank more efficient. Letter C, the movement of the fresh air to the septic chambers will be from this proposed vent or from the to expose to the long term. Okay, so this is my explanation. I just took it from a report that I used in one project, which we did inspection in the summer of last year. So just show it because this is a very clear. Let me just go back to that slide. No, again, you might think that when you flush the toilets, sewage water will be inside this, and that is true. When you flush the toilets, the movement of air to the vent through roof will be temporarily stopped every time you flush the toilets, because there's a big volume of water that is coming in from the flushing toilets. But the moment the process is normalized, when the dirt has come already to the digestive chamber and the excess water would have transferred to the settling tanks, and the excess further water is the processed water has already been thrown away to the drainage. After a while, air will come again inside here and there, and come out again in the vent through roof. And since the flushing of toilets will just happen maybe just a few seconds every time somebody uses the toilets, maybe 5 seconds, or maybe so you flush the toilet, how many seconds is that? Maybe up to 10 seconds. Then after that, the cross ventilation will happen. Okay, is that very clear? So let's proceed. I checked on American standards. Let us compare versus design standards in America. Here, there is this book by Lawin E. Silai. This is quite a thick book, which shows the simplest sewage treatment tank, and this is the top view of that septic tank, of the treatment tank, and this is the elevation view. You will notice that this American design shows equivalent 3 chamber. So this portion is the digestive chamber, and this is the settling chamber, and there is a third one which also an equivalent settling, because it separates the clearer water here to enter at the top of this venturi or nozzle to go out. But you take note that the cross ventilation can happen, like I was explaining. No, the air comes here, goes to this vent, enters this third chamber, goes to this T, comes out here, moves here, comes inside this T, and will exit to the VTR. So Mr. Lawin Silai also knows it, but of course there is no explanation in the drawing. They just simply show it. The vent here is provided to allow, the movement, to prevent the imbalance that may happen inside the septic tank. Let us see another slide. Here in the country, so many are making mistake by providing this T that would have a clean out at the top. Take note, these are T's, but the T's continue to the top of the tank. Here, this kind of installation also disallows cross ventilation, because you analyze it, the moment the digestive chamber is on the right side. It has a chlorinating chamber and a leaching chamber, but of course, as I've said, the leaching is no longer allowed. No more holes here. So the movement of the hair is stopped here. It cannot go to the vent through roof. So this I refer to it is design error number 1. many of our colleagues still do this design. Okay, let's go to the next slide. And here is the one that I mentioned to you earlier, where there was this subdivision where the contractor did some cost reduction by using elbows instead of T's. Instead of sanitary T's, the contractor used sanitary elbows as shown in this drawing. So take note, the digestive chamber is on the left side and the leaching is here. So when the air comes here, and since he uses a T, then again the cross ventilation will not happen in this kind of design. So it's a wrong design. Okay, so this one is wrong, this one is also wrong. Okay, and this is the third design error, number 3, which is the old design that is still in the revised National Plumbing Code. Even the book by Max Fajardo is still not yet revised, because the last revision, I believe, is before the Clean Water Act. I think the revision in the Fajardo book is 2003, I think, or 2002. The Clean Water Act came out in 2004. Now, I'd like to explain on this. Here you see the digestive chamber, and it uses T's, of course, no clean outs at the top, but it uses a leaching chamber on the second chamber, which is no longer allowed by the Clean Water Act. This gray water should no longer be allowed to reach the water table or the water aquifer. It's still dirty. It's many of our places here, our communities, the water table is too shallow. The aquifer is very shallow. Some of them are just farms that have been converted into housing. So definitely the water table is too shallow. As per the Philippine Clean Water Act of 2004, it is Republic Act 9275, the sewage water in the leaching well in this design may contaminate the underground water table. Henceforth, it is no longer allowed. Due to this, the settling chamber must now be consist of 2 sections to allow for longer settling period to produce at least a cleaner effluent. Okay, so what is the Clean Water Act? I took it from the law. The Philippine Clean Water Act of 2004, 9275 aims to protect the country's water bodies from pollution from land-based sources, industries, and commercial establishments, agriculture, and community household activities. So take note, household. So that means, therefore, the old septic tank is no longer will no longer pass this Clean Water Act. It's very clear. Okay. How will the discharge of wastewater be discouraged? Anyone discharging wastewater to a water body has to pay for wastewater discharge. This is a provision of the 9275, which is not good. Because why? Those who discharge dirty water just need to pay for a fine. And that's bad. That's the reason why the Boracay water in the sea has become too dirty, because of this provision of the Clean Water Act. It should be revised to remove this provision. In other words, or a big penalty should be meted out. Okay? This economic instrument was developed in consultation with all concerned stakeholders, was expected to encourage investments in cleaner production, clean water, and pollution control technologies to reduce the amount of pollutants generated and discharged. Okay, next slide. Among others, the Act prohibits, meaning the Clean Water Act, the following: discharging of or depositing of any water pollutant to water body, or such which will impede natural flow in the water body. Of course, this refers to the river or the creeks. Okay, discharging, injecting, or allowing to enter into the soil anything that would pollute groundwater. So this provision should be taken into consideration with the necessary revision of the National Plumbing Code, the 1999 National Plumbing Code. Okay, let's see the other provisions. Operating facilities that discharge regulated water pollutants without the valid required permits, and disposal of potentially infectious medical waste into the sea by vessels is also prohibited. Okay, next slide. Among others, the Act prohibits the following: unauthorized transport and dumping into the waters of sewage, sludge, or solids. So those are servicing the septic tanks cannot just transport this dirty water without permit. Okay, because we've seen in the past there are these servicing companies that would throw away their waste to the rivers, which should not be allowed. It's criminal. Transport, dumping, and discharge of prohibited chemicals, substances, or pollutants listed under the Toxic Chemicals, Hazardous, and Nuclear Waste Control Act, that is Republic Act 69, and discharging regulated water pollutants without the valid required discharge permit pursuant to this act. Non-compliance of LGU with the water quality framework and management area function is also prohibited. And here, next slide, refusal to allow entry, inspection, and monitoring, as well as access to reports and records by the DNR in accordance with this act. Refusal or failure to submit reports and or designate pollution control officers, whether required by the DNR in accordance with this act. And then, directly using booster pumps in the distribution system or tampering with the water supply in such a way to alter or impair the water quality. So, when you use a direct booster pump to suction the water supply, it's also not allowed because sometimes the water distribution company experiences low pressure, and if water outside of the pipes will enter the leaks, then there is a chance that this dirty water would contaminate the water inside the pipe of the Manila Water or Maynilad Water or the MWSS or the local water distribution company. Okay, operate facilities that discharge or allow to seep willfully or through grave negligence, etc. Undertake activities or development and expansion of projects operating wastewater treatment. So this has been there since that time in 2004, but we have known late last year at the outburst of the President of the Philippines that the water companies have not yet implemented, have not yet commissioned those community sewage treatment plants by the MWSS. Okay, here is another design which I took from the social media, which we use STs and specifies the airspace here at the upper portion of the chamber. So we have the digestive chamber, and here it mentions leaching. It should be settling chamber 1 and settling chamber 2. So this design is also acceptable. As you would notice, the air would move here, here, come here, come here, come here, enter here, and then it will go to the ventral row. So this detail of the septic tank is also acceptable. Okay, now here is a suggested schematic which would improve much better the present design of the septic tank. Which take note, here we have the digestive chamber and a leaching chamber here and a leaching chamber here, and we have added here what we call a sand filter. So you will notice there will be 4 chambers already: digestive chamber, settling chamber 1, settling chamber 2, and a sand filter that will make sure that the water coming out of the septic tank will be much cleaner, because the sand filter will trap any bacteria that might come out and go to the storm drainage system. So this could be adapted already. And here is another detailed design of it. It's the same, except that it is more of a shorter one with a wider design. So here is a digestive chamber, and here's the first settling tank, and here's the second settling tank, and it has here a sand filter, a gravel filter and a sand filter, and the effluent would come out of this. So take note that the sand filter are made shallower so that it would be easier to do maintenance with the sand filters. No, in other words, when you need to replace the sand, you can just open these service manholes and access and replace the gravel and the sand filter. It is also possible that you may have here a gray water tank after the sand filter, so that you can store the gray water, which it is possible to use as for irrigating the plants, or it can also be used to flush toilets or flush urinals. Okay? And here is our suggested sustainable design for the plumbing of our systems. No? Number one is the rainwater must be collected, filtered, and stored. Rainwater to fill up the fire water tank. May also fill up the domestic water tank. Surface rainwater runoff is collected. Condensate from ACUs is collected. Number 5, gray water from the septic tanks is sun filtered and stored for reuse. Gray water to be used for flushing toilets for irrigation. Number 7, use upfit system with inverter type constant pressure pumps. And of course, number 8, use solar energy to power up the pumps. So in a schematic, here is the idea. So here is a rainwater tank. So we collect the rainwater, provide filter to the downspouts, so that will make the rainwater much cleaner. And we provide a fire water tank for fire protection. And we have here the domestic water tank, where the water from the water company, local water company, would be stored for our domestic use, for our shower heads, for our lavatory and kitchen sink, no? Okay, and on the design of the septic tank, here on the right side, must be a distance of about 15 meters away from the storage of clean water. So you have the digestive chamber, settling tank 1, settling tank 2, the sand filter, and a gray water tank. The gray water tank must be sized adequately so that it will store this gray water for reuse to flush water closets and for irrigation. Okay, of course, the excess rainwater can fill up the gray water tank, aside from filling up the fire water tank. If adequate filtering is used, then it can also be used to temporarily supply water to the domestic water tank, especially during rainy season, no? When the water supply from the local water company is upset. Okay, so again, you will notice that the rainwater tank is sized larger. So again, we have to evaluate the available rainwater, okay, so that we can have much more of this. We can utilize the available rainwater. Okay, so let us have a short break. Okay, later on when we go back, we'll discuss a little on the chat group. Okay, we are back. We are back, and let us see our chat group who are there. Okay, so we have. Let me just address some questions that might be asked in the group chat. From Militario Marino, hi po sir, how much po yung certificate? Later on, we'll discuss about that. Then Son Yeager, about po sa certificate again. Well, let us not yet talk of the certificate. We want to finish first the seminar. Then after that, we'll discuss about the certificate. Definitely, we want to give certificates those who have finished the seminar. Okay. Many are asking certificates and certificates, no, but it is important that everyone will have to undergo first the seminar, because we do not want people to be asking for certificates, and if we give them and in fact they were not able to complete the seminar. Okay, so Mr. Rexter Valdez, hi sir, watching live. Interesting topic here, how to avail certificate. Same. Patrick Braza, good evening, good evening. Alfred Castro, good evening, likewise. James Onya, sir, may I request for a copy of the seminar? Yeah, well, we will be providing a PDF copy of this PowerPoint. I will get a certificate when I visit the office. Thank you. Arnel Ergisa, good evening to everyone. Good evening. Joy Cleofe, good evening, sir, and watchers. Okay. Cafe Akome, present po. Jess Mondehar, good evening, sir. Good evening, sir. Joy Clofe, sir, wala ba yung cursor? Nawawala. Sometimes the cursor is missing, no? And Ariel 2, the second Cruz, good evening, sir. Good evening. John Patrick Austria, present po. Michael Salveja, nasa magkano kaya yung certificate? Anyway, just to tell you, we used to charge very minimal at the MEP Center. So, it's still very minimal, don't you worry. What is important is the topics that we're discussing, especially in the design of the septic tanks. Like I told you, I have seen colleagues in the plumbing professions who still do not know how to design the correct septic tank. So, I'd like to emphasize this. Some are even lecturers by CPE, CPD groups, and they are signing and sealing wrong plumbing plans and septic tanks. No? Okay, so very important for you to know this. Otherwise, we might end up producing another dirty Boracay or another dirty Manila Bay. Jess Mondehar, very interested with this topic, sir. Thank you. Patrick Braza, sir, it would be helpful if may cursor. Sonia Yeager, present po. Cafe Akome, sir, ako rin, pa-request ng PDF. Okay. Sonia Yeager, sir, use pointer po. Cafe Akome, sanitary engineering students po ako. Very good. Okay, so I hope I was able to read all those there. So let's go back to the topic. Well, I will now. The course is too small, but anyway, I will try to circle the discussions. Okay, so that now here the next slide. Let me just go back to the anyway. No, here is a catch basin detail and a plumbing fixture schedule on the left side. So was included there in that large drawing earlier. My only comment in this typical design of the catch basin is that my suggestion is to provide a hole here at the bottom of the catch basin. So in other words, catch basin should be provided with an equivalent to a leaching hole, no? A small hole, something like 2-inch diameter, 2 to 3-inch diameter, or maybe just the bottom of the catch basin would just you just use gravel, no? So what is the reason? So the gravel bottom would just allow the leaching of rainwater to the ground. Okay, this would help in reducing flooding in the area, in the neighborhood. No? As long as it is not dirty water that you're going to allow there, no? It's just like the rain has just uh, uh, come down in the open yard. Okay, so here, this kind of design, which is completely, totally cemented, is only for dirty water. For the rainwater, it should have a hole here. Okay, so that's my suggestion in the revision of the National Plumbing Code also. Okay, here I just added here an easy way to size your bench, no? So here in the first column is the size of the bench, no? Or size of the waste stack from 1.5 to up to 6 inches, and on the next column is the fixture number of fixture units connected to it. So to do it is just see how many fixtures are connected in the planch. How many fixtures? If it is 10, then you could easily determine, of course, what size of or here, I'm sorry, here, the diameter of the vent required here on the right side. So, okay, so this is how we use this matrix. Very easy to use. No? Now we go to the plan itself. Here is a plan of the ground floor of that drawing we have shown earlier in the beginning of this PowerPoint. So take note of the blue line here, the entry of the water service, and then you have a gate valve here, and then of course the water meter here, and then a check valve, a gate valve and a check valve, and the water would go direct to the water cistern here. So an underground water cistern. Okay. So and of course there are some piping layout here for the toilet and baths here, and also shower. Let us see the larger presentation. So here is the water tank. Take note of this square blue lines. Indicates the underground water cistern. So it's about 1 meter by 1 meter by 1.5. So this is a small tank water cistern. But take note, there is a round tank here, which is the outline of the elevated water tank at the third level, at the third floor. Okay, and of course we have here a pump, a 1 horsepower pump here. So let's go to the next slide. And here is a blown up of the two, and the ground floor, the blown up of the toilet and bath here, shower and toilet, lavatory and water closet. And there is another toilet here, but there is no shower. So water closet and there is a shower. So it's a small toilet and bath. Okay, toilets and shower. And on the second floor, again there are a toilet here and another toilet here, and here is another toilet, quite a big toilet. Okay, so that's on the second floor, and necessary water line plumbing. Now on the third floor, you would see another toilet here and another toilet here. Okay, toilet and bath. And there is now the elevated water tank here. So take note, this is already the third floor. So elevated water tank above. So it's elevated from the floor. Okay, and the corresponding piping and valves and so on and so forth. And here is an isometric drawing, which is very important to show the complete flow of the water supply. Okay, here with the water cistern below ground there, and of course the elevated water tank here at the top. Okay, and on the right side is the the general legend. Again, here is the soil and storm plumbing layouts, soil pipe and storm drain layout. Okay, and this is ground floor. So this is the ground floor. The pink line or red lines indicate the catch basins and the storm drains pipe, no? And here also for the soil, okay, soil, and also for the storm drain catch basin. Okay, here we have the second floor storm drain layout. Here we have the downspouts here, this one and this one going there, and here also, and here and here and here and here. Okay, so this is the second floor. And the third floor, you would see again the downspouts here. This one, this one, this one, this one, this one, and this one. Okay, and again the isometric of the downspouts coming from the gutters. Okay, and now we go to isometric drawings of the sanitary. See, you would see the vent through roof here, and you would see this is on the second floor. You would see the water closet here and the clean out floor drains, and of course the lavatory here. You would see the vent here. This one is the vent, and also here. Okay, and also here, and also here. To make it very efficient, all fixtures like this floor drain and this lavatory, even the floor drain, should be provided with connection to the vent. That's the one lacking in this isometric drawing. The vent for this floor drain, the vent for this floor drain, okay, is missing. Okay, and for the kitchen sink also likewise, because it has here a trap, so there must also be a vent for this. So that's the one lacking in this, no, the connection of the vents. Okay, okay, I just added this just to indicate the details and the details for the vents, standard height of the vents. Okay, okay, so here is now the basement plumbing layout. It's not so clear, of course, and here the ground floor plumbing layout. It's not so clear also. And the second floor plumbing layout. Here the third floor plumbing layout. And here is the roof plumbing layout, where you would see also the catch basin down below, and of course the downspouts. Okay. Okay, so the basic needs and consideration before you do the plumbing design. Secure architectural base plan from the architect. Familiarize yourself to the prepared base plan. Study carefully and look for the best location for the septic tank, cistern tank, underground cistern, pumps, overhead tank, downspouts, catch basin, soil stacks, branches, water supply pipes and risers, pumps, water meter, and others. No, coordinate with the architect for the possible changes in the plumbing fixtures layout. laying out the pipes and fittings economically and maintenance friendly. Other points to consider in designing: rule of thumb for soil, waste, and vent design. Number one, make sure your plumbing pipe layout is accessible for repair and maintenance. So it is always better to install it maybe outside if it is possible. Next is, do not put your soil and waste lines on the center of the structure as much as possible. And number three, minimize turns or change of directions as much as possible. Okay, and then always provide clean out on every change of directions, end of branch, and on every foot of the stack. Okay, then provide clean out on every 15 meters length of straight soil and waste pipe line layout. The next is, always provide loop bend for every set of plumbing fixtures. Okay, so my suggestion here is, for every fixture we have to provide a vent so that the venting will be more efficient. Once water closet is present, the minimum pipe diameter must be 4 inches. All plumbing fixtures discharge must be trapped except for the water closet, because the water closet already has a built-in water seal. Always inspect the waterproofing application procedure and test for leaks. Then, last but not the least, always test the pipes installed for leaks before closing the ceilings, because it's very difficult if you do not test it and there are leaks later. So you might end up with a back job. Okay, the next rule of thumb for cold water line system: 20 mm diameter pipe can supply water from 3 to 6 pieces of 12 mm diameter water supply pipe to fixture served. Always provide gate valves to every fixture served. Always provide check valves to every upfit riser. Always provide air chambers as much as necessary. Do not over-design the capacity of pumps. Consult manufacturer. Do not let your water line cross the waterproof toilet flooring. Provide bypass when there is cistern or overhead tank. Okay. Maintain 20 psi water pressure to your water system as much as possible. Provide booster pump as necessary. Always test the water pipeline of leaks before finishing works application. Okay, next. Okay, so here is a blown up plan of the basement floor plumbing layout. So here we have the basement floor at this upper portion where you see a sump pit here, a maid's room and a sump pit, and a toilet and bath here on the other side. So from the toilet and bath, it will go to the sump pit, and from the sump pit, the septic tank is on the ground level. So my suggestion is, as much as possible, refrain from providing a toilet in the basement, because even if you have a sump pump here in the sump pit that would pump the sewage up to the septic tank to the ground level, there is a problem when your sump pump will deteriorate and will not function later, no. I'm just being reminded that the Glorieta explosion in 2007 was caused by a toilet or restrooms located in the basement of the Glorieta 2. And of course, they have sump pit also there, but the sump pumps did not function after a while. And even the maintenance people of the Glorieta 2 were not able to immediately replace or do maintenance on the sump pumps. Eventually, sewage water accumulated in the sump, and accumulating too much sump water or sewer water, which produce methane and hydrogen sulfide, which when maybe a spark was created, just like maybe somebody plugging charging cell phone, and then suddenly you unplug this charger, there would be a spark, and this might have ignited the methane that has accumulated, methane and hydrogen sulfide that was accumulated. So that's the reason why I would strongly suggest to architects or to builders or to the owners not to provide these toilets in the basement. It is always safer to provide the toilets at ground level, so that when you flush the toilets the sewer water, the sewage would just flow directly outside to the septic tank, and no need to be accumulated in a sump pit like this one. Okay, so here you have the cars, and there is gasoline in the car, plus a methane that could be produced in the sump pit if the sump pump is not functioning. So, it could be a double whammy, Okay, on this far bottom side, on the left side, is the swimming pool. Here you have the pool, and here is the filter room. The filter room, here's the filter and the filter pump of the swimming pool. Okay? Okay, so this one is just a blow up of that toilet and bath for the maid's room. No? So this is as I was telling you, I would suggest not to provide this in the basement. You better put it in the ground floor, so as to not to have a sump pit which could accumulate dangerous toxic gas like methane, highly flammable, and hydrogen sulfide, which is highly toxic. Okay, so here is the ground floor plan, but let us see the blow up succeedingly. But take note, and here is the septic tank. Okay, septic tank, and this is drainage to street drain. So with here, okay, what else? And here is the water cistern here, and here is the swimming pool and the filter room. Okay, here just to show the typical detail for plumbing by for the service. No? So you have here the water service, then the incoming isolation valve, the water meter, and the check valve, and usually you should have here another gate valve after here. No? But we also have noted that even the Manila water do not have another one here, only on the incoming. The green portion is being provided by the water service company. Okay, here. Okay, so now here is a blow up of that, the septic tank here. So there are 3 entries here, here, and here, and then we have the effluent coming out here. And here for the storm drain, this one, storm drain, because this present design doesn't have a rainwater tank. So course, this is the one that is not included. By the way, this original presentation was prepared by architect Flynn Aranya, who is also a master plumber. I was not able to mention it earlier, but in the cover slide, his name was included. Is there, no? Okay, here is the another part of the ground floor plan and the kitchen and powder room area and the cistern area. So here is the powder room, the kitchen, the den, and the cistern tank here. Okay. Okay. And here is the details in the swimming pool area. Swimming pool, and here is a shower area of the swimming pool, service area here, and of course the filter tank room is below. It's below. Okay. Here is now the detail of the pump, pole pump, filter, and a filter room. Anyway, with regards to the details of doing a swimming pool, we had conducted this last night. You can refer to an earlier video that we had yesterday. No? Swimming pool design, operation, and maintenance. And here is just a schematic for the swimming pool, just to see the different parts, like the waterline level, return inlet, skimmer, main drain, a three-way bulb here, pump motor, the water heater, backwash, the drain, and the circulating pump. Okay, the return line, return inlet, and so on. Okay. And here is another typical design drawing coming from the presentation yesterday, swimming pool design. Components: main drain, vacuum, skimmer, return to pool, backwash, and the overflow. Okay, just to show. Now here we have the second floor plan, plumbing layout. Okay, so we have here the toilet and bath on this side and another one on this side. So let's take a look at the details. No, so this toilet and bath is for the master's bedroom, and this toilet and bath is for the guest room. Okay, here is the toilet and bath for the guest room. Okay, and here is another toilet and bath, the one in the master's bedroom. Okay. And just a typical toilet and bath, where you would see here I was talking about the vents, no? As much as possible, we should have vents in every fixture. Okay, to make sure that your venting is most efficient. So let's go back. Here is now the third floor plan, and you would see the overhead tank at this portion here, this lower portion. 300 gallons stainless cylindrical overhead tank, and here you have 30 gallons stainless cylindrical pressure tank, because this is the storage for the water, but here you have a pressure tank with the pump. So because the pressure at the third floor and at the second floor is not so strong, so you need to use a pressure pump. Okay, so let's go to the next. Here is the other toilet and bath at the third floor. Okay, and details of the elevated water tank, larger blow up drawing. Okay, here I have shown two slides just for the computation of the uh, domestic water tank, the capacity of the domestic water tank. I took this sample from the Max Fajardo guide, no? In page 107 of the book by Max Fajardo, this one is for a 4-story sample, no? 4-story building has 11 water closets, 11 lavatories, 9 showers, and 3 kitchen sinks. Locate the maximum or calculate the maximum demand of water. So, water closets, 11 times 6 units per closet, 66 units. Lavatories, 11 by 1 unit per lavatory, 11. Showers, 9 by 2 units per shower, was 18 units. And then kitchen sinks, 3 times 2 units per sink is 6 units, for a total of 101 units times 8 units, 8 gallons per unit, for a total of 808 gallons. 808 gallons times 3.78 liters per gallon is equivalent to 3,054 liters. So you may use a 3,000 liter stainless steel tank, okay, or even a larger one if you wish. Now, here is another example for an 11-story building. And similarly, compute for the size of domestic water tank. Okay, 11-story building has 110 water closets, 110 lavatories, 110 showers, 110 kitchen sinks. Calculate the maximum demand of water. So water closets, 110 times 6 units, 660 units. Lavatories, 110 units times 1 unit per lavatory, 110 units. Showers, 110 times 2 units equals 220 units. And then kitchen sinks, 110 times 2 units per sink is equal to 220 units, for a total of 1,210 units. Okay? So estimated maximum demand of domestic water, 1,210 units times 8 gallons per unit, or 9,680 gallons. Okay. So, if you're providing fire sprinkler system, you have to calculate the capacity of the fire water tank, okay, by calculating the friction loss or hydraulic calculation for the fire sprinkler system. And then you have to compare the volume calculated for domestic water to that of the volume calculated for fire water. Whichever of the two will have a bigger volume, my suggestion is to use this bigger volume as also the volume of the other tank. Like for example, in a previous computation, the fire water tank is 12,000 gallons, but the domestic water tank is 9,680 gallons. So therefore, my suggestion is follow the capacity of the fire water tank. It should also use 12,000 gallons. Okay? So that's the idea. Now here we have pumps required, water booster pump, water pressure pump. The one that is there at the third floor is a pressure tank. And a constant pressure pump can also be used because this is very much more efficient than the ordinary booster pump. Later on, I will explain to you how this functions. And of course, 2.4, a sump pump in case you have a parking area. Okay. So a booster pump is one that would transfer water from your water cistern at the ground floor or at the basement to your elevated water tank. If you're still using the one that is indicated in the drawing prepared by architect Flynn, it uses of a water pump booster pump transferring water to the elevated water tank. Okay, so upfit water distribution system. So this is my suggestion on how to calculate the capacity of that water pump. Okay, using the 3,000 liter capacity, that's equivalent to 800 gallons divided by 30 minutes assumed time to pump water. So you will need a 26.7 gallon per minute water pump. And for a 60-foot head, a 40 GPM capacity rating motor drive is a 1 horsepower 230 volts single phase 60 hertz pump. Okay, here is a detail for a pressure pump. It's a pressure tank, small pressure tank, plus the pressure pump. And here are just typical water service provision. And the first column is for 3 levels only, 3 floors. And on the middle is a 7-story. And on the right side is also another with an elevated water tank. So this was what was in the design. We have a cistern here. With a pump, you transfer water to the elevated water tank and by gravity. Okay. The middle portion is what we call the pressure pump system. Okay. And of course, if the water service has a strong pressure, then there's no need for a booster pump, just like in the middle. Okay. Like for example, many places here in the Marikina Valley have a strong water pressure. It can even the water from the Manila water can reach up to the level of fifth level. Even at especially during night time. Okay, so but to make sure that you will not have problems of lack of water, it is always better to have this receiving tank and the elevated water tank, the old design, or having an upfit system like in the middle where there should be no booster pump located here, but there should be a cistern. Okay, so here is the conventional design that I was talking about, which is common in our urban centers. So here, this red rectangle here at the basement receive water from the water company. Here you have the gate valve, and here the water meter, and with a float, so it fills up this tank. And there are 2 pumps here. One is a running pump and the other one is a standby pump to transfer water to the elevated water tank here. And then from the elevated water tank, water would be distributed to the different floors below by gravity. So this is the conventional design. You always spend an equivalent of energy bringing the water to the top. Even if you want to bring the water to the second floor, you always spend electricity and the pump to bring the water first to the roof deck and bringing it down to the second floor or to the third floor or fourth floor, etc. Now, the upfit design is different. This is the upfit design. The upfit design uses a constant pressure BFD, meaning variable frequency drive pump. The one that has introduced this technology was Wilo Pump of Germany. Now today, Grundfos already has this, and I believe maybe some other pump companies has already also have their equivalent model for this Wilo pump. The Wilo pump is same as this picture below, where you see 4 small pumps, 4 with very small pumps with a bladder tank here. Okay, so these small pumps are running on variable frequency drive, and here on the left side with a box here is the what we call the variable frequency drive controller, a pump controller which is different from the usual pump controller that we are using. It's a variable frequency drive, or sometimes we refer to it as the inverter controller. Okay, and the right picture is another schematic showing the upfit piping. Take note, there's no more the pipe that is bringing the water down from an elevated water tank. No more elevated water tank and no more downfeed pipe. Only an upfeed pipe is provided. So therefore, this willow pump, which is an inverter pump, a variable frequency drive pump, is economical because there is no more tank at the top. You need only one tank on the ground floor or on the basement, wherever it. No? And of course, you will notice that even if it shows here 4 small pumps, these pumps are only having a capacity of 1.5 horsepower each. No? This one is 1.5, this one is another 1.5, this another 1.5, and this another 1.5, for a total of 6 horsepower capacity. They run like in parallel, sometimes helping each other, sometimes, and of course their speed is varying depending on the number of faucets open upstream, upstairs. When there are more faucets and shower heads are open, the pumps will run faster, will rotate faster in order to increase the capacity of water to be delivered to the different faucets and shower heads. If there are lesser faucets and shower heads that are open, then the pumps would run more slowly. So you see, it's a lot different from the present conventional design. The present conventional design has a single speed. It has only 2 situations. One is stop position, and the one is at full load speed position. While in here, it could be rotating at 1,800 revolutions per minute, or it could be rotating only at 1,200 RPM, or maybe only 800 RPM, or maybe only 300 RPM, or maybe only 100 RPM. Of course, correspondingly, with the lower speed, the volume or the flow or the pressure would become lower also. That's how it functions. So it's really a different design than the conventional design. Now, this makes this Willow, the constant pressure pump system, very, very efficient. It could save an equivalent of 80% of the cost of pumping of a conventional system. In a project where I've used this, 4 units of 1.5 horsepower, what we replaced is 10 horsepower pump. I repeat, these 4 1.5 horsepower Willow pumps replace an equivalent or a 10 horsepower pump. And mind you, that system that was replaced had 2 10 horsepower pumps. No? One is a running pump and the other one is a standby pump. Okay, so that's why although this one has a more expensive first cost because of the additional controller and the additional feature, in the long run, it is much, much better, more efficient than the conventional design. Okay? Here's other picture of the willow, where here on the left side is just a single pump. So a single pump here, and a bladder tank here, and the controller on the right side. At the top is a single pump, not showing the controller. And here is the more modern design, where you have here the bladder tank on the header, and there are two pumps working in parallel. And here is a three pump combination. A three pump combination. What is not shown here is the bladder tank, but the BFD controller is here. This box here in the upper portion. Okay. And here is a closer look at the controller, which you would see the status of it, no? Okay. So it is a variable frequency drive controller with these indicators. Okay. And here are the general features. The Willow is excellent energy saving, up to 80% of savings with the BFD. It is anti-rust, various pump protection functions, pump load distribution, frictionless compensation, inverter alternating cycle, operating by skipping the faulty pump, and then application, water supply and pressure boosting, residential areas and townhouses, motels and small buildings, fire extinguishing pump, so it can also be used as a fire pump, industrial circulating system, boiler water supply, coolant system. So that's the uses of this constant pressure or Willow pumps or the ground force. Okay. Willow pump sizing. So Willow provided this Quick Start, MHIK Quick Start. For example 1, for a 140 room accommodation, 3-story dormitory building, the selected model is MHIKE W804, or 2 units of 2.5 kilowatts motor. Okay. In example 2, 60 rooms accommodation, 11-story hotel, the selected model is also MHIKE W804, 2 units of 2.5 kilowatts. Here, this upper circle shows the W804 here, the upper portion. The cursor cannot be seen, no? I'm trying to move it here, but cannot be seen. Anyway, this is for the 11-story building design, this one. And this one on the lower right is the dormitory of 160 units, 140 accommodation. This is another drawing which in this the cursor could be seen, W804 here for the 11-story building, and this one is for the W804 also for the 3-story dormitory. And here is the typical MHIKE W804, where you see 2 units of 2.5 kilowatts Willow pump. Okay. Okay, so pump sizing for larger volumes. You can also follow this sample that I've done. Just using 10,000 liters to 645 gallons divided by 15 minutes pumping, 176 gallons per minute. So you can specify the 4-stage Willow pump, 120 foot head, 176 gallons GPM capacity, and the rating of the Willow motor would be 4 units of 1.5 horsepower. Here I just added here this from from Google, just to show simple computation of head. This head here, dynamic head. Okay. Preparing the plumbing material specification. General instructions in proper shipment or delivery on the site, including methods of storage. Must be aware of the function or purpose of each plumbing pipes, fittings, and fixtures. Must be aware of the method of installation for each material specified. Must have knowledge of durability of each of the materials specified, and to specify the plumbing material from each texture, size, and use, including manufacturer, provide dealers, contact person, numbers, and brochures, which is optional. And last but not the least is testing and project duration. Preparing the plumbing bill of materials. Must have a complete plumbing layout both for cold water line and soil waste vent and the storm drainage system. Must have knowledge and quantity of materials from the smallest fittings to the huge one. Must be similar with the plumbing pipe, familiar with the plumbing pipe, fittings, fixtures, materials, technical specifications, and commercial standard sizes. Must be similar with or familiar with the current market price of each of the materials required, specified in per unit cost. Must be familiar in labor costing, overhead, and profit costing, including taxes. Must have basic knowledge in preparing bill of materials in MS Excel. Then note, always provide cost for temp facil, storage, temporary facilities, electric, power, water consumption, and other miscellaneous expenses during construction. Use of tools involved in installation, and of course, safety devices. Okay, so we have here 3 successive slides showing the sample estimate. Okay, this is the first slide of the estimate. This is the second slide, a little clearer. And here is the third slide with the total cost here at the bottom here. Okay. Plumbing requirements and securing plumbing permits. Prepare 6 sets of plumbing drawings. Then next, prepare 3 sets of plumbing materials specification. Number 3, prepare 3 sets of plumbing bill of materials and labor. And here, fill out plumbing permit forms, 5 sheets. Then here, duplicate the PRC Master Plumber license or Sanitary Engineer license, front and back. Duplicate PTR Professional Tax Receipt. All of the above documents must be duly signed and sealed and submit to plumbing section of the building officials, office of the city of your location for evaluation. Then payment of fees, then wait for release of permit through verification. You know, sometimes the approval by the office of the building official sometimes takes some time, no? But you can always have use a transmittal letter when you submit it to the building official, so that you will have a documentation on how long they will be processing your plumbing building permit. Okay, so that you know, there is a law that would put a maximum of 15 days. I think 15 days approval. And I know President Duterte do not like this very long, and I remember one time before he mentions not more than 3 days or 4 days, I think. Anyway, so of course you have to follow up these building officials for the earlier release of your plumbing permit. Okay, basic knowledge as professional. Securing professional tax receipt. Okay, beginner. If you are a beginner in plumbing practice, present your master plumber's PRC ID together with duplicate to the city treasurer's office for professional tax. Then, renewal. Just present your old PTR, the original. When? Every January of the year. The first working day of the year. Here. Okay? Then, note, do not lose the original and or the rest of your PTR official receipts. Why? Because if you do, you will start from the beginning again to pay. They will charge you again. Okay. Then, how if I passed the board 10 years ago before I secure my PTR? Answer, cost of PTR per year, the current year, multiplied by 10 years. And that is how much you will pay the treasurer's office when you first secure your professional tax receipt. The amount of our professional tax receipt is 300 pesos. Okay? Always secure residence certificate for the employed. Is the cedula. Okay? Then, signing plumbing permit forms. Always sign the upper box intended for the plumbing designer. Then, if not in charge of the project, do not sign the lower box. But it can be negotiated. That is if another fee is arranged for you to, the client will pay you for signing the person in charge. Okay, next slide. How to charge your client based on the project plumbing cost for your professional design services fee. For plumbing design services, compute a probable plumbing cost of your project. Okay. Number 2, make your own standard average costing per toilet, kitchen, septic tank, cistern, and other appurtenances per size of structure. For you could easily come up with your ballpark figure. Then apply the available table fees under the uniform plumbing uniform rate, approved and implemented in March 4, 2001. Okay. Then, now you would know how much professional fee you are going to charge your client. Sample computation for design fee. Say project cost determined by ballpark figure is 1 million. So under plumbing uniform rate is 2%. So your professional fee can be 20,000. Okay? Is this fee commensurate to your job? Will you not supervise your design? This work will run for 6 to 8 months project duration. Sample computation for purely sign and seal services. For a 2-story residential with 2 water closets, 2 shower heads, and 2 lavatories, and 1 kitchen sink, and 3 faucets. Okay, so here, based on the given uniform rate, first plumbing unit will be charged 500 peso per unit. And succeeding plumbing unit, say an additional of water closet, urinal, shower, and so on will be charged 200 pesos per unit. Okay? Now, based on the given plumbing units, you have 10 plumbing units. So, computation, first plumbing unit, 1 unit times 500 pesos is 500 pesos. Then, succeeding units, 9 units times 200 is 1,800 pesos for a total of 2,300 pesos. Plus, if they will ask you to sign the in-charge, signing for the in-charge is 500. Today, I think 500 is very small for signing the in-charge. Yours truly usually charge up to 3,000 for the in-charge. Okay, 3,000. Okay, so total master plumber professional fee would now become 3,000 plus 2,003 is 5,300. Of course, that can be negotiated. Okay, here is a copy of the uniform rate or charges in 2001 as mentioned earlier, but I think this is already very old, needs to be upgraded, need to revisit for revision. So there are times when your design needs to be revised. So how much more can you charge, no? So here, computation for plumbing design fee for small house, a plumbing cost total of 30,000 below 250,000. Okay, so 4% is 1,200. Okay, expenses, draftsman fee 700 pesos, estimate and specs 500 pesos, plotting 120, blueprinting 6 copies 72, okay, Xerox 20, fair 100 for a total of 1,512. So when you compare it with this by percentage basis, here it is much lower than in here. Okay, computation for sign and seal only for small house, 1 water closet, 1 shower, 1 lavatory, 1 kitchen sink, 1 house bib. Therefore, first plumbing unit is 500. Succeeding units is 4 times 200, 800, plus in charge 300. Again, this is very small. You should charge much more. So total professional fee 1,600. So anyway, this is just example, huh? But I believe the in-charge fee is very small. Okay, how to create owner, master plumber, plumbing professional contract agreement. Contract content. Put client's name and address and your name and address. The name of your project, what is your involvement to the project, date of signing, the scope of works to the given job. If design services only, put your total professional fees and other fees including mode of payments from down payment, succeeding payments, and final payments scheme. For installation services, attach the detailed bill of materials and labor that will serve as reference for billing purposes and accomplishment report, and will serve as total project contract price. Mode of payment, down payment with notice to proceed or NTP, balance in progress billing. Then other clause in the contract is subject between you, your agreement with your client, including force majeure, stoppage of work, delay of payments, and additional works, and so on and so forth. Then, of course, project duration and the warranty. Okay, so that's it. That's the here is now the page of the comment of Architect Flynn. Sana po ay natuto kayo sa aking binahaging kaalaman tungkol sa pag-asikaso kung paano gumawa ng kumpletong plumbing documents. Bilang isa sa mga kailangan sa pag-secure ng plumbing permit mula sa building official at sa ating professional practice. Bilang isang registered master plumber. Signed, Architect Flynn Aranya. In English, I hope that this sharing is added to your technical know-how on how to prepare plumbing documents needed in the securing of plumbing permits with the Office of the Building Official. Okay? As a registered master plumber or plumbing professional. Thank you very much. Signed, Architect Flynn Aranya. And here is also my last message. Ang pagiging master plumber or plumbing professional ay simula lang para makarating sa mas malawak na profesyon, ang maging MEPF engineer. This is my comment, o kaya MEPF practitioner. Mahalaga ito sa buhay ng isang plumbing practitioner dahil ang profesyon na ito ay laging kaakibat na mechanical, electrical, at fire protection practice. Hindi andar ang water pump kung walang electrical. Hindi gagana ang bomba kung hindi dahil sa mechanical pump. Ang fire sprinkler system naman ay kailangan ng mga tubo para dumaloy ang tubig na pamatay sunog. Dapat ihanda ang sarili oportunidad na ito. Okay? What I was telling here in English is that being a master plumber or plumbing professional is just the start of a wide, significant practice in the technical profession, including MEPF or mechanical, electrical, plumbing, and fire protection. It's very important that plumbing practitioner, the plumbing practitioner knows this because the practice includes today includes mechanical because of the pump, electrical because of just like I mentioned the variable frequency drive, and the fire protection. Okay, because there is a need to provide sprinkler system to our buildings nowadays. The pump will not run without the pump will not run without the mechanical side of it, and the sprinkler system will not also operate without the fire pump and the electrical system. So therefore, it is very important that integrated practice of mechanical, electrical, plumbing, and fire protection should be considered. Okay, so that's the last slide. Thank you very much. So now we'll proceed to the I'll just go back to the cover slide, or to that my emphasis on that cross ventilation design. Yan. Okay, so let's proceed to the chat room. Okay, let me start on the bottom of the chat room. Nestor Reyes, Engineer Nestor, thank you. PISAM past President Engineer Willie, and the PISAM National Board of Trustees member Architect Flynn Aranya, another quality technical seminar. Yes, thank you, Nestor. Engineer Nestor Reyes is our National Auditor of the Philippine Society of United Master Plumbers. Dexter Cardihon, sir, maraming salamat po. You're welcome. God bless. And Dexter, John Patrick Austria, thank you, sir. Paano po certificates? Yes, we'll discuss about that later. Ariel 2, second, thank you, sir. Welcome. Joy Clopas, thank you, sir. Welcome. Sonny Ger, thank you. I think I've read this earlier, but let me go back to some long questions. What can we do on the effluent from the third chamber if the main sewer is not available, Okay, if we do not have Kent Molina, Kent Anilom, if we do not have uh, a uh, a main sewer like a storm drain, let's say for example in the farms, then you have to provide a gray water tank. The gray water tank will store the water, which you can use it to uh, for irrigation purposes, maybe, and even flushing the toilets. So uh, that is one way of using it. Okay. Uh, it is also possible to provide reed plants in that around your gray water tank, so that the roots of the reed plants, just like bamboo. Bamboo is a plant that has roots that has the capacity to clean the impurities in sewage water, in gray water. Okay. Okay, another question from Kent Molina. Sir Will, is the dimension of the third chamber same with the second settling chamber and designing a three-chamber septic tank? Okay, like, this, no? The plumbing code says that in the original two-chamber design, the second chamber must be one-third of the volume of the first chamber. The first chamber is the digestive chamber. So, I repeat, whatever is the volume of your digestive chamber, your third chamber, the second chamber in the old design should be at least one-third of the volume. So, you can make therefore this the second chamber supposedly divided into two, so we will have three chambers. Okay. But that is a minimum requirement of the code. You can always make the size larger to allow for longer staying of the dirty water inside your settling tanks. Okay. And by the addition of the sun filter that I was suggesting, then that will improve. My suggestion for my fellow members of Philippine Society of United Master Plumbers, as well as those who are practicing MEPF, is to add a sand filter to your design. Let me just go back to that slide where I put the sand filter. Sorry, I'm going back to that. Here. So you will see the digestive chamber, the settling tank 1, settling tank 2, the sand filter, and a gray water tank. The gray water tank could be made larger. So let me go back again to the chat. Okay, so that's the idea, Ken. I hope you were able to get it. Sir Will, dimension of the third. Okay. Arsenio Valdez, hello sir. Good. Pwede po makahingi ng copy for review ko na lang, mahina signal. Yeah, we'll be giving you through email. Just indicate, please message me through my messenger. Will J. Juan, take note of my Facebook messenger. Will J. Juan, PE, RMP, MEPF, and TTE. Will J. Juan. Okay, and then here, Rexter Valdez, sir, pwede po magkasama sa general notes yung material specifications as per other design kasi hiwalay yung specifications sa general notes. Yes, you can also separate it, especially usually it's being included in the bill of materials, or in a separate written specifications. Okay. Jerome Ben, good evening sir. Present po. Yes, acknowledge Jerome. Rolly Dumriga. Yeah, Rolly, kumusta ka na? Sir Willie, ask po ako ng certificate and copy of this file. Yes. Alfric Avinsay, Lodi. Thank you. John Dogo, Sir Will, mag-request po sana ako ng soft copy ng presentation of the certificate po. Yes, thanks. Okay, thanks Jan. And good evening, okay, Jan Docos. Then Emil Mbile, please advise po for the request of PDF files of this presentation and the certificate. Thank you for this very informative topics webinar. God bless. Yes, welcome. Eunice Angke, good evening sir. Pahingi po ng PDF file. Discussion tayo. Yes, we'll do it. Rolly, good evening sir. Yes, good evening Rolly. Michael Salveja, sir, pwedeng makahingi kami ng soft copy. PowerPoint sa discussion natin. And yes. Tapos soft copy discussion nyo regarding sa swimming pool. Yes, okay. We'll do also. Rexter Valdez, hi sir. Ilang toilet po ang kaya ng 4 inches diameter sewer pipe? I think it's no problem with that. You can put as many as you can in that 4 inches pipe. Okay. Romel de la Cruz, sir, pwede bang makahingi ng PDF? Yes. Rexter, what is the most practical way on the execution of waterline pipe? Is it on the floor, ceiling, or wool? Hot and cold water line. Okay, so he's asking where you put the waterline pipe. Is it on the floor, ceiling, or wall? Of course, usually all of these are being placed in there. No, sometimes on the floor, sometimes on the ceiling, and sometimes on the wall. We know PPR is now recommended for use for water supply because of its higher pressure capacity. The old PVC industry, the PVC technology has been defeated by the PPR. Why? Because the manufacturers of the PVC pipe did not improve their PVC cement. Oh, remember, their PVC cement is not strong enough to hold the joints of the PVC pipe against the pressure that passes through the water pipes, and that's the reason why the PVC pipe, the blue pipe, is no longer the best pipe to use. Of course, the GI pipe before was used, galvanized iron pipe, but of course very expensive. Copper is also very expensive, much more expensive, so it's not popular in our country. No. Thank you, sir. Carlo Mateo, thank you, sir, for this free webinar. Yes. John Ray Dante, sir, may factor ba ang storm surge sa pagbara ng holding or septic tank na katabi ng tabing dagat? Port. Storm surge, and of course, when you have water coming in, just like the Typhoon Yolanda, definitely that will cause back pressure to your system. Okay, so usually the storm surge is not a regular phenomenon happening. No, when the storm surge, the Typhoon Yolanda storm surge happened in Tacloban, it enunciated up to three floor height houses or buildings in downtown Tacloban. So really, it's a different phenomenon that will happen. The only way to protect urban centers for this is to provide some seawalls. Seawalls is the only solution, which I think is the public works is building some of this. No. Okay. Romel de la Cruz, good evening, sir. Thank you for the good topic. Yes, welcome. Jan Patrick Austria, bakit di pa po gaanong na-implement yung 3 chambers for septic tank? It is now being implemented, Jan Patrick. The only problem is many of our practitioners are not yet knowledgeable. That's the big problem. Okay? Cafe Acome is a student. Okay? Patrick Braza, sir, is Fajardo book updated? I think no. The last updating was 2003, I believe so. So it needs also updating by the author. But I think the author is already 80 years old. Maybe I will talk to Engineer Leo Fajardo, the one who originally wrote the swimming pool design presentation last night. So, for him to update it. No? Sanitary engineering students po ako. Yes, Cafe Ecome. Yeah. No problem, Cafe Ecome. No? Sir, use pointer po. Yeah, I've been trying to use it. Sir, ako rin, pa-request. Okay, I think I've read this already. Let me go back to the bottom again. Ray Anthony Palomo. Sir Ray Palomo, present po. Yes. Hello, Vijay Poligrates. Sir, yung 500 po ba for first unit is plumbing unit, fixture unit? Yes, I think it's a plumbing unit. A plumbing unit, and then the succeeding is 200 fixture unit. Okay. Arsenio Valdez, request rin ako ng certificate. Okay. Ray Anthony Palumo, sir. Okay. Patrick Plaza, sir, what you advise old houses na yung water lines are made of GI pipes because some of the pipes that is exposed are showing signs of corrosion. Well, if they are very old pipes already, they've been there for 20 to 25 years, our suggestion is to do repiping already, and use PPR for this. Use PPR, okay? PPR is the best way to use for our water lines today. Salamat po, sir, sa sobrang informative. Angelo Israel, sir, hingi po ng copy. Yes, okay. Aferin Joy Bernardo, or this engineer lady, Aferin is in Singapore. Soft copy po. Thank you, sir, for sharing your knowledge. Yes, God bless. Patrick Braza, sir, I had read the book of Sir Fajardo, and in my own opinion, sir, madaming error. What book could you advise as an alternative? Thank you. Well, because it's an old book, it's still based on the 1999 National Plumbing Code. That's what I was telling you. That's why there are so many lacking. No, I remember in one project in the Visayas last year, I was in conflict with the sanitary engineer there because even the sanitary engineer could not appreciate my idea of the cross ventilation. My provision of the cross ventilation. This lady sanitary engineer would just insist telling me that the septic tank, the bacteria there are anaerobic and they do not need air. I told her that all living being needs air or needs oxygen. So even the bacteria needs oxygen. If you deprive the bacteria inside the digestive chamber of oxygen or free air, that bacteria will die. And if it dies, then your digestive chamber will not function well for its purpose. And that is not in the textbooks. That is not in the Fajardo book. That is not in our plumbing book. That is not in other books. The sanitary engineers just have insist on providing the sewage treatment, the centralized sewage treatment. That's the reason why, but the problem is most of our homes still are provided with the standard septic tanks. But it must now be designed with 3 chambers, and my suggestion is to be provided with that sand filter. You can also add a carbon filter if you want to. And you can even add a chlorination process if you really want to make that water much cleaner before throwing away to the bodies of water. Okay, some more message here. Ariel Tucros, sir, will pahingi. Yes, we'll do it here. Okay. And who else? Fernando Bautista, sir, will, how about po computation ng sprinkler heads according to sizes ng pipes? It's a different topic, Fernando. Well, we'll also discuss this in the future. Hydraulic or friction loss calculation of automatic sprinkler system. We will discuss it in a separate topic, okay? So here we just discuss more on the proper design of the plumbing, especially what is not yet included in the 1999 National Plumbing Code, which is already 21 years old. And of course, we have there the Clean Water Act, which many of us, like I told you, still do not consider the provisions of this Clean Water Act. And that's the reason why the water in the Manila Bay has become so dirty. And that's the reason the water also in San Juan River has become too dirty, in the Pasig River, and also in Boracay before. But of course, the government has now implemented more strict measures, and we plumbing professionals must now come to the front, come to the fore to make our practice to a higher level, a much higher level, so that we can make sure that the water that we throw away to the creeks, to the storm drainage, to the rivers, to the lakes, and to the sea are not to contaminate these bodies of water, which is as provided for in the Clean Water Act. Okay? Any more? Okay, here there's another question from or message from Angelo Israel. Sir, ano pong minimum separation distance ng water supply line at output of septic? I think it's 15 meters. But of course, we have I've seen some locust housing where you have the distance between the septic tank and the water tank. So my suggestion is in these very small properties, my suggestion is the water tank should be located at the back. Water tank should be located at the back, and the septic tank should be located in the front. So that will maximize the distance of the water tank and the septic tank. Okay, to make sure that the water would be much cleaner. Patrick Brasa, thank you for sharing. Yes, welcome. Okay. So with regards now to the certificates, we can issue the certificates, no problem. We will just be asking for a minimal fee. You know, at the MEPF Center before, we starting last February, we started charging 500, but since we are now using this live webinar, no need to go there to the MEP Center. We just need a fast internet. Our certificate fee will be only 300. So, but just make sure that you really have virtually attended it. So, I don't want that we will be issuing certificates for those who have not attended or have not seen the video after it is uploaded by YouTube. After this live stream, in 24 hours, YouTube will upload it just like my previous YouTube live stream. And after that, those who were not able to watch this live stream will be able to view the videos, just like how you could view any uploaded video on YouTube. Okay? So, please send me message or via my Facebook Messenger, Will J Juan PRM, WJ Juan PRM, or you can also message me in my two other accounts that I'm using, William Jacinto Juan 1 and 2. You can, no? I can answer you there in those two accounts, but it's easier to send me message to use the Will J Juan PRMP Facebook Messenger, or you can also send me through email. Okay, so it will be much easier because the Will J Juan account is in this desktop. Okay. Okay, Herbert Soyat, maraming salamat po sir for sharing your time. You're welcome, Herbert. Okay. Is there any question more that you'd like to me to give you an answer? I hope I was able to emphasize very clearly the need for that cross ventilation system, and also the need for rainwater harvesting, the need for adding a sun filter to our present septic tank design, and also the need for adding a gray water tank so that we can use this gray water for irrigation, and also can also be used for flushing the toilets. As you could see, the we have separate pumps, no? Separate pump for the flushing the toilets here, and separate pump for the domestic water for the showers and lavatories. And of course, this one is for pump for the fire water. Okay. Okay. What else? So my real emphasis is the our compliance to the Clean Water Act, and this will put our level of practice to a higher level, because the old septic tanks really are so bad in design, especially now that the urban centers are, I mean, the population has increased and increased in the years, no? In the old plumbing code, 1955, then it was updated in the 1990s, and I mean 1993, I think, and then updated in 1999. From 1999 until presently is not yet updated, so we must come to the fore. Okay, any more questions? I'll be giving you maximum of 3 minutes for more questions. Emil Mbile, sir, may I know how the mode of payment for the certificate? Any bank accounts? Yeah, I'll be posting that. I think if you have a GCash, that could also be possible. If you have a GCash, it's very easy. You can always go to the 7-Eleven. It can also be through the bank accounts. But of course, by the way, the original copy of the certificates will have to be sent via courier. So it's not included in the fee that I told you. It's not included in the 300. Okay. So we'll be trying to deliver it to your address by the courier, maybe JRS, LBC, or some others, and they will collect it from you. I will also try if we could send it via the Philippine Postal, because there is one here nearby in my place, Cainta Post Office. If I could get that, then it will be much cheaper, I believe. Okay. We'll put the certificate in an envelope, a brown envelope, and send it to you. Okay? Okay, so any more? Oh, Michael Salveja. Hi, hanggang saan yung filter sun above pipes or below pipes, intake and out? Okay, the sun filters, I can give you my latest design on that. It's not yet so detailed in this PowerPoint, but I already have done some design for this that already shows the effluent pipe for this sun filter, so I can share it to you. And the desired thickness of the gravel, the big gravel and the smaller gravel, and the sand. Okay. Okay, Marlon Pascual, Sir Will, is it feasible na magkaroon ng centralized sewerage system sa Pinas? Oh my God, the STPs are there. Remember when President Duterte blew his top because there was no water last year, and then Manila Water and Maynilad was charging, they won an arbitral ruling in Singapore in billions. And in fact, when the president checked on the provision of the contract between the government and MWS and the Maynilad and Manila Water, we found out that these STPs are not yet done. It's not yet finished. Okay? So the only STPs that we have are in the private. The ones being constructed by the Manila Water and the Maynilad, I believe are not yet completed. So that's the big problem. No? That's the big problem in urban centers. Okay, then what else? Uh-huh. The centralized sewage treatment is what that is that is what the sanitary engineers are designing. But the problem is, in many subdivisions, there are no STPs. There are no STPs. Like today in Pasig, Manila Water is constructing this um, in Pinagbuhatan, in Ilugin. It's one of the biggest STP. They started constructing it maybe 5, 6, 7 years ago, but up to today it's not yet done. And Maynila is also doing an STP in Valenzuela, but it's not yet done. In Muntinlupa also. And there is also one in Magallanes Village in Makati, and there is also one in UP, a small one in UP. And there is also one in La Mesa Dam. Okay. Still ongoing construction. So, if you're going to wait for this, the water will will be contaminated already. That's the big problem, Marlon, no? Marlon Pascual. Okay, Senando Bautista, Sir Will, baka po pwede ma-post ang messenger nyo po for communication. Let me see if I can post it here, ha? In here. I cannot. Anyway, WILJUANPEE Will J. Juan, o pwede rin yung William Jacinto Juan, or just message me William Jacinto Juan. Okay. Rexter Valdez, last question, sir. Same elevation lang po ba lahat ng T-pipe sa chambers? No, they're sloping. The elevation should also be sloping. No, meaning the downstream chambers must be going down. Okay, must be going down. But little just to allow the flow of water to the last chamber. Okay, but as I have shown in the T's, let me just go back to that again. There is one correct design. This one, it is going down. It is going down. It is going down. Okay, this is a good design. But let me just emphasize here. So there's the air gap. Okay. Here I did not show 3 chambers, but the idea is 3 chambers. Okay. Just to show the movement of the air going to the vent roof. Okay. I hope that should be very clear. Any more questions, ladies and gentlemen? Any more questions? Anyway, we can still discuss about this through chat in the future. If anything will come into your mind, no problem. Okay, so I hope I was able to drive points on very important details. Okay, Marlon Pascual, thank you po, Sir Will. Mag-request din po ako ng soft copy and certificate. Yes, we'll do it, Marlon. No? And okay, so we can now we have already lagged how long? It's already almost 9 o'clock. So from 6:30, 7:30, 8:30, so it's 2 hours and 2 hours and 26 minutes. Okay, so we will end up our live stream by 9 o'clock. We still have 4 minutes because we still have going to have our closing prayers. By the way, those who are already registered Master Plumbers, we encourage you to join the Philippine Society of United Master Plumbers. Okay, in your just inquire in your localities. In Metro Manila, you can contact me. In Cebu, there is the very strong group there, headed by Engineer Avelino or Boy Masong. And in other centers, there are chapter presidents already. Just message me if you want to, so we can guide you so you'll be able to join them. No, you will be issued IDs. And on the part of the MEPF Organization of the Philippines, those who may want to become certified MEPF practitioner or engineers can also send your request for certification via mepf.org@yahoo.com. Okay? Michael Salveja, pwedeng 2 affiliations, sir, PISAM or NAMPAP, it's up to you. You can, it's your own free will. Of course, I was telling you, I was also a NAMPAP member before, but in 2012, I had to distance myself from NAMPAP because, in 2010, I already paid for my lifetime membership as NAMPAP lifetime member, but the management then of NAMPAP did not give me a lifetime membership card. There were many complaints, so our groups then, together with the group of Cebu and Cavite and Manila and Quezon City, NAMPAP Quezon City, which is now today the PISAM Quezon City, where one of the examiners, Colonel Camilet, is also a past president of the NAMPAP Quezon City chapter. Of course, now is the PISAM Quezon City chapter. Okay, so my recommendation is for you to join PISAM, because I believe PISAM is the, in PISAM, and of course the PSP, Philippine Society of Plumbing Engineers, both PISAM and PSP want to upgrade the master plumber to become plumbing engineer. And in 2014, our group, with yours truly as the leading, as the leader of our PISAM before, worked out for the possible passing of the plumbing engineering law. As a matter of fact, in Congress, it was at the time approved. The House bill there was approved, but the problem was in the Senate. The chairman then was Senator Trillanes. As you know, Senator Trillanes did not act on the bill. So up to this time, it is not yet approved. But hopefully in the future, the PISAM will again work it out for its approval. Unfortunately, the NAMPAP leadership do not like to upgrade it to plumbing engineer. That I do not understand. Okay, so that's the reason why I suggest that you go PISAM, because PISAM is the one that wants to upgrade the master plumber to a plumbing engineer. Okay, I hope I was able to explain a lot. Okay, and Michael Salveja, Calamba chapter, Sir PISAM. Yes, there is contact engineer Armando Diaz, because he is from Cabuyao. Okay, and there are also many master plumbers in Calamba. Okay, ladies and gentlemen, now we're going to close. We'll have our closing prayers. In the name of the Father, Son, Holy Spirit. Amen. Thank you, Lord. We praise you and thank you for allowing us to be able to conduct this live stream on this technical topic, preparation of plumbing, sanitary plans. Thank you, Lord, for always guiding us and giving us this opportunity to be of service to our brothers and sisters. Lord, we ask that you continue to guide our practice, our family, guide our, keep us away from the sickness and from accidents. And of course, give us good practice so that in the future we will flourish and we will make progress with our lives. We ask through this in the mighty name of your Son Jesus Christ, who lives and reigns with you. Amen. Of course, there are some pahabol. Let me see. Ray Anthony, Pisam, Quezon City. Yes. Ray Anthony Palomo, sir, count me in. Okay, yes. Okay, yun na. Okay, so again,